In this video lecture, we're going to discuss regular grammar. But let us define what is grammar. So grammar is a finite collection of rules that defines how we're going to create a sentence, a good sentence. In computer, we also have computer grammar that we need to follow so that we could have a good program. So this grammar or computer language is um, presented by, conceptualized by Noam Chomsky. So it's a mathematician, and based on his concept, so there is a mathematical model of grammar which is effective for writing computer languages. And based on his concept, we have four types. Okay, so we have type 0, type 1, type 2, and type 3. And by the way, this is Chomsky. Okay, so let's go back with type 0. So if say type 0, this is unrestricted grammar. So, and also the grammar or the language of type 0 is being recognized by a Turing machine. So type 0 includes type 1, type 2, type 3 grammar. So basically it's just a collection of other type. Okay, and the accepted language for type 0 is recursive sensitive language. Okay, so in type 1, so this is context sensitive grammar. So the language being accepted by this grammar type is context sensitive language, and it is being accepted by linear bound automaton. And then in type 2, that we're going to discuss on the next video lecture. Okay, so it is a context-free grammar, wherein this grammar is being recognized by a pushdown automaton. And the language that we're going to discuss in type 2 is context-free language. And the type 3, which we already discussed in module 1 and module 2, which is the regular grammar. And the accepted language is the regular language. And this is being accepted by the machine, which we called the finite automaton. Okay, so type 3, regular grammar, which we already discussed. And then type 2, context-free grammar, that we're going to discuss on the next video lecture. And then type 1, context-sensitive grammar. And type 0, unrestricted grammar, that will be accepted by Turing machine. Turing machine will be discussed on the last part of the term. Okay, so if say grammar, so we denote it by capital G, and it can be represented or described by four tuples. So we have V, T, S, P, where V is the finite non-empty set of non-terminal symbol or set of variables or non-terminal symbols. Okay, and for T, these are finite set of terminal symbol, while S, it is the start symbol, and P is the finite non-empty set of production rules. If say production rules, these are the rules that we use to create the string, okay, on our language. So a production rule can be as a form of from A map to beta, wherein A and beta are string on V union with T. So basically, this A and beta came from the set of non-terminal symbols and terminal symbols. Okay, and also it could be belong to just one non-terminal symbol. Okay, So that will be production rule. So further discussion of this will be on when we are discussing the examples. Okay. So again, we have BTSP. V non-terminal, T terminal, S start, P rules in determining the string acceptable by the machine. Okay. So let's have this example. So again, G is grammar, and we have these four tuples. So the first tuple is SAB, second AB, then we have S, and then we have S, then AB, A, then A, B, then B. So what are the meaning of this? Okay, so going back to the fourth tuple of grammar, so SAB is basically the non-terminal symbols. Okay, and for AB, these are terminal symbols. So these are the string or the variables in our string. Okay, and then S is the start state, and the symbol with arrows are the production rule. Okay, so basically production rule give us an idea how to create the string. Okay, the acceptable string of the machine. Okay, so let's have this production rule. How we're going to define what are the strings that can be um, accepted by the machine. So always start with the start terminal, which is S. So start terminal based on the production rule, start terminal will yield to an AB. AB is non-terminal. Okay, so non-terminal. And in our second rule, we have A, then small a. So it means that this capital A could be replaced by a terminal small a. So we have A capital B. And the third rule, we have B, then small b. Again, B is non-terminal and B, small b, is terminal. And based on this rule, we could replace the capital B by small b. So we have small a, small b. So since these are terminal symbol, therefore, this is an example of accepted string by the machine. Okay, and that's how we use the production rule in determining the accepted string. Okay, and we also have two types of regular grammar. We have right linear grammar, this is linear, and left linear grammar. So how could we determine which is which? So based on the location of the terminal variable or terminal variable. Let's have this example. A, then X capital B. We all know that capital A and capital B are non-terminal, while small x are terminal variable. As you can see here on the first example, the terminal variable is before the non-terminal, or it's on the left, on the non-terminal, okay, non-terminal variable is on the right side of the terminal variable. Okay, right means the non-terminal is on the right side of the terminal variable. Okay, so again, A, where A and B is an element of non-terminal and X is an element of terminal. So example, we have a start, which is S, then AB, small ab, capital S, pipe B. If you see this symbol, it means or. You could have this substitution for S or B as substitute for S when we generate the string. Okay, but going back, if it's right linear, as you can see, S is a capital S is on the right side of the terminal variable. So that's right linear. Okay. Now let's move on with the left linear grammar. So left linear, it means that the non-terminal symbol is on the left of the terminal symbol. So again, A, B are non-terminal and X is terminal. So based on this example, A, then capital B, small x, wherein B is on the left side of the small x. So therefore, this is left linear grammar. Example, S, then capital S, small b, pipe, small b. So again, pipe means either of these two string we can substitute capital S. Okay, going back with left linear grammar, capital S is on the left side of small b. Non-terminal is on the left side of terminal symbol. So that's left linear. Okay, so that's the end of our video lecture. So just a summary, grammar are set of rules that defines the sentences, the language, acceptable language. Okay, will it be in English or will it be on computer language? And Chomsky give us an idea how to have an effective computer language. And we have four types, type 0, type 1, type 2, type 3. The simplest is type 3, type 2, and then type 0. Everything, type 1, type 2, type 3 is part of type 0. And we have two types of grammar. We have left and right. And the grammar could be represented by four tuple. So first, V, okay, non-terminal, capital T, terminal, S, start, capital P, production rule. Okay, so that's it. See you on the next video lecture. Thank you.